I was standing still because the orders had nothing for this moment. My weight was on the ground, and the ground had already decided what it was. The system said wait, the manuals said withdraw, and neither could move my foot. I understood then that survival was not an action, but a restraint. By the spring of 1942, the war in North Africa had settled into a pattern of movement, pause, and violent interruption. The western desert stretched between Egypt and Libya as a broad, exposed battlefield where distances were long and cover was scarce. Armored formations maneuvered across open ground, supply lines ran thin, and both sides relied heavily on obstacles to slow the enemy. Among the most effective of those obstacles were mines, laid quickly, often marked poorly, and sometimes forgotten even by the units that placed them. At this stage of the campaign, British Commonwealth forces were reorganizing after earlier setbacks. Defensive positions were being reinforced along likely axes of advance, while engineer units worked continuously to improve mobility for friendly troops and deny it to the opposing side. Minefields became a routine feature of the terrain. They were planted by the thousands, in lines or clusters, sometimes mapped carefully, sometimes recorded only in field notebooks that might be lost or destroyed. In the desert, wind and drifting sand could erase warning signs within days. The operational situation placed unusual demands on combat engineers. Their work was rarely visible in official reports, yet it was constant and necessary. They built roads, repaired airstrips, bridged wadis, and, just as often, removed hazards created by their own side. Mine clearance was slow and deliberate, requiring patience more than strength. It was also work performed under pressure, as advancing units depended on cleared routes to maintain momentum. Within this environment served a junior non-commissioned officer attached to an engineering detachment supporting an infantry brigade. His responsibilities were ordinary for his rank. He supervised small working parties, inspected ground before movement, and ensured that equipment was used according to standing instructions. He had arrived in North Africa months earlier and had already seen how quickly conditions could change. He understood that the desert gave little warning. What appeared stable one day could become dangerous the next. His daily routine began before dawn. The cooler hours were reserved for the most precise tasks, when hands were steady and concentration was easier to maintain. He reviewed orders issued the previous evening, checked tools, and assigned men to their sections. Mine detectors, probes, marking tape, and simple hand tools were laid out carefully. There was little margin for error and no room for haste. The area under their responsibility lay near a secondary supply route. The road itself was little more than a compacted track, bordered by open sand and low scrub. Intelligence reports suggested that no enemy forces were immediately nearby, but the road had been used repeatedly by different units over the previous weeks. Mines could have been placed deliberately, or they could have been displaced by vehicles, erosion, or shell fire. No one could be certain. Standing instructions emphasized caution. Men were to advance slowly, scanning the ground, probing when necessary, and marking any suspected devices. The officer followed these rules closely. He had learned that discipline was the only reliable defense against accidents. Overconfidence was dangerous, and improvisation was discouraged unless absolutely required. Despite these precautions, early signs of limitation were already apparent. The mine detectors in use were effective against metal-cased devices, but many mines in the desert had minimal metal content. Wooden or bakelite casings were increasingly common. Probing remained necessary, but probing itself carried risk. Each downward movement of a probe required judgment. Too much force could trigger a pressure mechanism, too little might miss the device entirely. The detachment had already encountered difficulties in recent days. A marked lane cleared earlier in the week had shifted under the sand, its edges blurred by wind. A vehicle passing too close had exposed a buried mine that had not been recorded on any map. It was removed without incident, but the discovery reinforced a shared understanding that existing records could not be fully trusted. The officer took note of these issues and adjusted the pace of work accordingly. He reduced the distance covered in each shift and insisted on repeated checks of cleared ground. This drew quiet frustration from some of the infantry units waiting to move through the area. Delays were unwelcome, especially when higher command expected rapid progress. Nevertheless, he maintained his approach, aware that a single mistake could cost lives. On the morning in question, the task appeared routine. The team was to verify a previously cleared section of ground near the road's edge. Vehicles had been observed passing through the area, and there was concern that the surface might have been disturbed. The officer walked slightly ahead of the men, watching the ground rather than the horizon. His attention remained fixed on subtle changes in texture and color, the small indicators that suggested something beneath the surface. The sun rose higher, and the temperature increased. Gloves became uncomfortable, but they remained in use. Tools were exchanged quietly as needed. There was no conversation beyond what the work required. Each man understood his role and followed it. At one point, the officer paused to examine a shallow depression partially filled with sand. It could have been caused by a vehicle wheel or by natural settling. He marked the spot and began a careful inspection. The probe met resistance sooner than expected, though not at a depth consistent with most known mines in the area. He adjusted the angle and tried again, encountering the same resistance. This was not unusual, but it warranted caution. He signaled for one of the men to hold position and leaned closer, brushing away sand by hand. The shape beneath the surface remained indistinct. There was no visible casing, no clear outline, only a sense that something solid lay beneath. The officer considered the possibilities. It could have been debris, a buried container, or a mine placed deeper than usual. The absence of clear metal response made detection uncertain. Standing instructions advised withdrawal and marking for later removal if identification could not be made safely. He chose to proceed slowly. Without shifting his weight significantly, he extended the probe again, this time from a different angle. The resistance remained. He withdrew the tool and prepared to mark the location. As he adjusted his position, his boot pressed into the sand at the edge of the depression. There was no immediate sound, no visible movement. Nothing suggested that anything had changed. He did not realize in that moment that his weight had come down directly over a concealed device. What followed did not resemble the sudden, violent detonations described in training manuals. There was no sharp report, no spray of debris, no visible blast. Instead, there was a muted mechanical sensation, a brief shift beneath his foot, followed by stillness. The ground did not erupt. The air remained unchanged. For several seconds, no one spoke. The officer froze, instinctively aware that something was wrong, but unable to identify exactly what had occurred. He did not move his foot. The men behind him remained in place, sensing the change in posture and tension. He slowly raised a hand to signal them to stop. His expression remained controlled, but his attention was fixed downward. Whatever lay beneath his boot had responded to pressure, yet it had not exploded. The possibility that he was standing on an armed mine became increasingly difficult to dismiss. Training offered limited guidance for such a situation. Pressure-operated mines were designed to detonate under weight. If one failed to do so immediately, it could still be unstable. Any sudden movement might complete the action that had begun. The officer weighed his options. He could attempt to shift his weight away gradually, though this risked triggering the mechanism. He could call for assistance, but that would require others to approach the area. He could remain where he was until specialists arrived, though time itself carried risk under the rising heat. He chose to remain still. The decision was not dramatic. It was the result of habit and instruction, reinforced by an understanding of how little could be done safely without further information. He signaled again, indicating that the area was dangerous. One of the men carefully backed away to relay the situation to the section leader. The desert around them remained quiet. No enemy fire interrupted the moment. There was only the sound of wind and distant engines on the road. The officer stood with his foot planted, aware that a device beneath him had not behaved as expected, and uncertain whether that failure was temporary or final. This pause marked the end of routine work and the beginning of an unplanned test of procedures that had never been designed for certainty. The message reached the section leader within minutes. It was delivered quietly and without embellishment. One of the men reported that the officer had halted after feeling movement beneath his foot and believed he was standing on an armed mine. The description was brief, factual, and deliberately restrained. In mine work, exaggeration served no purpose. The section leader understood the implications immediately. He ordered the rest of the working party to withdraw along their marked path, retracing each step with care. Tools were left where they lay. No one rushed. The cleared lane was narrow, and any deviation risked compounding the problem. Within a short time, only the officer remained forward of the position, isolated by necessity rather than choice. Standard procedure dictated that no one approach an active pressure mine unless absolutely required. The safest response was to stabilize the situation and request specialist support. However, the operational environment imposed constraints. Dedicated mine disposal personnel were stretched thin, supporting multiple units across a wide front. Response times could not be predicted with confidence. The section leader established a perimeter at a distance considered safe under normal circumstances. He consulted the available maps and notes, though none indicated a mine at that exact location. This absence of record did not offer reassurance. It only confirmed what experience had already taught them. Documentation lagged behind reality. From his position, the officer remained still. He was conscious of the weight distribution of his body, aware that even minor shifts could alter the pressure on the device beneath him. Training emphasized minimizing movement, maintaining balance, and avoiding sudden changes. He adjusted his breathing to remain steady and controlled. Panic would introduce errors. Communication between the officer and his section leader was limited to hand signals and brief verbal exchanges carried by the wind. The officer reported what he had felt: a slight depression, a mechanical response without detonation. He could not identify the type of mine, only that it had reacted to pressure in some manner. The uncertainty complicated decision-making. Some pressure mines were designed with anti-handling features or delayed action components. Others were prone to malfunction due to age, sand infiltration, or manufacturing defects. A failure to detonate once did not guarantee safety. In some cases, it increased danger. The section leader considered available options. One possibility was to attempt controlled removal by carefully excavating the sand around the officer's boot. This required proximity and exposed additional personnel to risk. Another option was to attempt to neutralize the device remotely, though this depended on knowing its construction. Without identification, such attempts could worsen the situation. Doctrine offered general guidance, but few solutions for this precise circumstance. Manuals assumed that a pressure mine would either detonate or not be engaged. They did not account for partial activation with no immediate explosion. This gap between written instruction and field reality was familiar to those working in the desert. Time passed slowly. The sun continued to rise, increasing heat and discomfort. The officer's leg began to stiffen, though he avoided any movement that might be perceived as a shift in stance. He remained focused on maintaining his position, using the butt of his probe as a light support without transferring weight. After further assessment, the section leader requested assistance from a nearby engineer platoon known to have experience with similar devices. The message was sent by runner and radio where possible. In the meantime, the perimeter was maintained and the road was temporarily closed to traffic. Waiting introduced its own risks. Extended exposure increased fatigue, and fatigue reduced precision. The officer was aware of this and attempted to conserve energy. He did not speak unless necessary. His attention remained fixed on the sensation beneath his boot, alert for any change. Eventually, an engineer sergeant arrived to assess the situation from a distance. He examined the ground through binoculars and reviewed the limited information available. He did not approach immediately. Instead, he discussed possibilities with the section leader, drawing on experience rather than certainty. Several factors complicated the situation further. The mine's casing, if present, remained buried. The lack of visible metal suggested a low metal content device. Sand conditions varied across the area, and shifting dunes could conceal or expose components unpredictably. There was also the possibility that the mine had been damaged previously and was no longer functioning as intended. The sergeant recommended caution above all else. He advised against attempting to lift the officer's foot without first understanding the mechanism involved. At the same time, he acknowledged that prolonged immobility carried its own dangers. Circulation, muscle control, and concentration could deteriorate. As the discussion continued, the officer remained in place, listening only when information was relayed directly to him. He followed instructions precisely, adjusting nothing unless told to do so. His role had narrowed to a single task: remain steady and responsive. The situation exposed a growing tension between official doctrine and the realities faced by those implementing it. Manuals provided frameworks, but they could not account for every variable encountered in the field. Decisions increasingly relied on judgment, experience, and a willingness to accept calculated risk. By mid-morning, it became clear that waiting indefinitely was not a viable option. The heat was intensifying, and support resources were limited. A decision would have to be made using incomplete information. The officer was informed that an attempt might be made to identify the mine by careful excavation at a distance from his boot, removing sand incrementally. He acknowledged the plan without comment. The work would proceed slowly, and he would be required to maintain his position throughout. There were no guarantees. The absence of detonation so far could not be interpreted as safety. As preparations began, the routine nature of the day had fully dissolved. What remained was a controlled effort to resolve a situation that doctrine had not anticipated and that equipment could not fully address. The outcome depended not on force or speed, but on patience and restraint. The decision to proceed marked a shift from routine procedure to adaptation. It was not announced as such, but everyone involved understood that the situation had moved beyond what standing orders fully addressed. The engineer sergeant selected 2 men to assist him, choosing those with the most experience in manual clearance. Their task was limited and specific: remove sand gradually from the area adjacent to the officer's boot without disturbing the ground directly beneath it. The approach was cautious. The men advanced only as far as the marked lane allowed, stopping well short of the officer's position. They lay prone to reduce pressure on the surface and used small tools rather than full-length probes. Sand was brushed aside rather than lifted. Each movement was deliberate, followed by a pause to observe any change. From his position, the officer could not see the work being done. He relied entirely on instruction and sound. He was told when to remain completely still, when to adjust his posture slightly to relieve strain, and when to report any sensation beneath his foot. He complied without hesitation. The responsibility he carried was understood, but it was not discussed. As sand was removed, the outline of an object began to emerge. It was partially buried, its upper surface flattened and obscured by grit. No metal components were visible. The shape suggested a pressure plate, though its exact type could not yet be identified. The absence of obvious damage indicated that the mine had likely been laid deliberately, rather than displaced by accident. The engineer sergeant halted the work once the edge of the casing was exposed. Identification was critical before proceeding further. He examined the visible portion through binoculars, comparing it to known designs. Several possibilities were considered. Some mines of this type were known to have inconsistent detonation characteristics, especially under shifting loads. One possibility stood out. There were documented cases of pressure mines that required a specific threshold of force to complete the firing sequence. If the pressure was applied unevenly, or if internal components were compromised, the mechanism could engage partially without detonating. In such cases, releasing pressure could either render the mine inert or complete the sequence. There was no reliable way to know which outcome would occur. This uncertainty placed the officer at the center of the risk. Any action he took could determine the result. The engineer sergeant explained the situation plainly, avoiding speculation. He did not offer reassurance beyond what could be supported by evidence. The officer was informed that the mine had not detonated under his current weight distribution, but that changing that distribution could alter the internal state of the device. The unofficial adjustment came quietly. Rather than attempting to lift the officer's foot or remove the mine in place, the engineer sergeant proposed a controlled redistribution of pressure. The idea was to gradually transfer weight away from the center of the pressure plate without creating a sudden change. This was not a method described in manuals. It was derived from experience with faulty devices and a practical understanding of mechanical tolerances. To do this, the officer would need to lower himself incrementally, shifting weight onto a prepared support while maintaining contact with the ground. The process would be slow and physically demanding. It would also require precise coordination between the officer and the men assisting him. Before proceeding, the ground adjacent to the mine was reinforced. Sandbags were placed carefully, ensuring they rested on confirmed safe ground. A wooden plank was positioned to distribute weight evenly. Each placement was checked and rechecked. The goal was to create a stable alternative support before any movement occurred. The officer was briefed on each step. He was instructed to move only when told, and only by the smallest possible amount. He acknowledged the instructions calmly. There was no indication of hesitation, though the risk was clear. The first adjustment was minimal. He shifted a fraction of his weight onto the support, maintaining full contact with the mine. No sound or movement followed. After a pause, the engineer sergeant signaled for the next step. The process repeated, each movement separated by careful observation. As the transfer continued, the officer became acutely aware of the physical strain involved. Muscles that had remained static for hours were now required to engage with precision. Balance was critical. Any slip or misstep could produce an abrupt change in pressure. He focused on maintaining control, using his training to regulate movement and breathing. At one point, a slight settling was felt beneath the sandbags. The work stopped immediately. The engineer sergeant assessed the situation, ensuring that the supports remained stable. The officer was instructed to hold his position until further notice. The pause lasted several minutes, during which no further change occurred. The work resumed cautiously. Increment by increment, the officer reduced the load on the mine. The men assisting him monitored the exposed edges of the casing for any sign of movement. None was observed. The pressure plate remained level, suggesting that the internal mechanism had not advanced further. Eventually, the officer's weight was largely supported by the prepared structure. His boot still rested on the mine, but with minimal force. This intermediate state was considered preferable to complete removal in a single action. It allowed for assessment at each stage. The final step required the officer to lift his foot just enough to clear the surface. This was the most uncertain moment. The engineer sergeant acknowledged this openly. There was no way to predict the exact response of the device. All that could be done was to proceed as carefully as possible. The officer waited for the signal. When it came, he followed the instruction precisely, lifting his foot by a small margin and placing it onto the support. The movement was slow, controlled, and deliberate. There was no immediate response from the mine. The team did not react. No one moved. The absence of detonation did not mean the danger had passed. Mines could be triggered by vibration or delayed mechanisms. The engineer sergeant instructed everyone to remain still for several minutes. Only after this interval did he allow a slight withdrawal. The officer was guided backward along the prepared path, retracing his movement carefully. He did not look back at the mine. His attention remained on maintaining balance and following instruction. Once he was clear of the immediate area, the mine was marked for later disposal by specialized personnel. No attempt was made to neutralize it further that day. The priority had been to remove the officer safely, not to resolve the hazard entirely. The risk had become personal, not through dramatic action, but through prolonged exposure to uncertainty. The unofficial method employed had succeeded, but it was understood that success did not validate the approach universally. It was a response to a specific set of conditions, applied cautiously and without assumption. As the officer rested under shade, the physical effects of the experience became apparent. Fatigue and stiffness set in, and water was brought to him. There was no celebration. The men returned to their duties quietly, aware that similar situations could arise again without warning. The incident was noted briefly in the unit's records. The language used was factual and restrained. It described a mine encountered, an officer exposed, and a successful withdrawal. It did not elaborate on the method used or the uncertainty involved. The operational problem had not been eliminated. The minefield remained, and the limitations of doctrine persisted. What had changed was an understanding among those present that not all risks could be managed through prescribed procedures alone. The immediate danger had passed, but the incident did not end with the officer's withdrawal from the mine. Its consequences unfolded more slowly, shaped by institutional processes rather than explosive force. Within hours, a brief report was transmitted up the chain of command. It was written in the neutral language typical of field summaries, listing time, location, personnel involved, and outcome. The wording emphasized that no casualties had occurred and that the device remained marked for later clearance. What the report did not fully convey was the degree to which established procedures had been set aside. The controlled redistribution of weight, the improvised support structure, and the decision to proceed without specialist disposal equipment were all departures from doctrine. These choices had been made deliberately, but they existed in a gray area between necessity and regulation. By the following day, questions were raised at brigade level. The presence of an unrecorded mine near a supply route prompted concern, and an inquiry was initiated into how the device had been missed during earlier clearance. Responsibility was not immediately assigned. The records were incomplete, and several units had operated in the area over the previous weeks. The incident was treated as a systems failure rather than an individual one. Attention soon shifted to the method used to resolve the situation. An engineering officer reviewing the report noted that the withdrawal had been achieved without detonation, despite prolonged pressure on the mine. This observation prompted requests for clarification. The section leader and engineer sergeant were asked to provide additional detail, which they did reluctantly and with care. Their statements focused on observable actions rather than interpretation. The officer at the center of the incident was not asked to testify immediately. He returned to duty after a short period of rest and resumed routine tasks. There was no formal recognition of his role, nor was there any suggestion of fault. From an administrative perspective, the matter was unresolved but contained. As further reports circulated, the improvised nature of the response drew mixed reactions. Some senior engineers expressed concern that such methods, if widely adopted, could encourage unnecessary risk-taking. They argued that doctrine existed precisely to prevent individuals from improvising under pressure. Others acknowledged that doctrine could not account for every situation, and that rigid adherence might, in this case, have led to worse outcomes. This tension was not new. Throughout the campaign, discrepancies between written procedures and field conditions had been a recurring issue. Equipment shortages, environmental factors, and operational tempo often forced adjustments. The mine incident became one more example cited in internal discussions, though it was never elevated to a formal case study. The mine itself was eventually destroyed by a disposal team using standard methods. Its design confirmed suspicions: a low metal content pressure mine with a simple firing mechanism prone to partial engagement under uneven load. Examination suggested that internal wear or sand infiltration may have prevented immediate detonation. The findings were recorded, but distribution of the information was limited. Despite this technical clarification, no changes were made to official manuals in the short term. The process for updating doctrine was slow, and the war's demands left little room for revision. Instead, knowledge continued to pass informally among engineers, shared in brief conversations and practical demonstrations rather than written directives. For the officer involved, the incident altered his relationship with authority in subtle ways. He was not reprimanded, but he became more aware of the boundaries within which decisions were judged after the fact. Actions taken under uncertainty could be interpreted differently once risk had passed. This understanding influenced his conduct in later operations, reinforcing a preference for caution even when time pressure increased. The unit itself experienced a period of heightened scrutiny. Clearance operations were reviewed more closely, and additional checks were required before routes were declared safe. This slowed movement temporarily, drawing frustration from other formations. Yet the memory of the incident lent weight to the engineers' insistence on thoroughness. No public acknowledgement was made. There were no citations or commendations issued in connection with the event. In the context of a campaign marked by large-scale engagements and significant losses, a near miss involving a single mine did not warrant attention beyond the immediate command structure. Still, among those who had been present, the incident carried lasting significance. It reinforced the understanding that survival in such roles depended as much on restraint as on action. The mine had not detonated, but it had imposed limits on movement, on procedure, and on certainty. As operations continued and the front shifted again, the event receded into the background of daily work. It was not forgotten, but it was not discussed openly either. Its influence remained indirect, shaping decisions quietly rather than altering policy. The stakes had reached their peak without spectacle or noise. What remained was an unresolved question within the system itself: how to reconcile the need for adaptable judgment with the demand for standardized control in environments where neither could fully prevail. In the months that followed, the war in North Africa moved on with little regard for individual incidents. Lines advanced and retreated, units were reassigned, and priorities shifted as larger operations took precedence. The mine incident was absorbed into this broader movement, reduced in official memory to a brief entry in engineering logs and clearance reports. The officer continued to serve with his unit through subsequent phases of the campaign. His duties remained largely unchanged. He supervised clearance work, inspected routes, and trained newer personnel in basic field discipline. If the incident affected him, it did so quietly. There was no outward change in demeanor, no visible mark of the experience beyond a heightened attentiveness to routine details. Institutionally, the response was minimal, but not entirely absent. Engineering units received informal reminders emphasizing patience during clearance operations and the importance of verifying previously cleared ground. These reminders were not framed around the specific incident. They appeared instead as general guidance, avoiding reference to any deviation from doctrine. The system absorbed the lesson without formally acknowledging its source. The absence of recognition was consistent with the period. Near misses rarely generated commendations, and survival without casualty was often treated as an expected outcome rather than an achievement. Official honors were reserved for actions that fit established categories of bravery or leadership, typically under direct enemy fire. The mine incident, though dangerous, did not align neatly with those definitions. Over time, the technical understanding of mines improved. Later manuals incorporated broader cautions about faulty or partially activated devices, though these additions emerged gradually and without attribution. They reflected accumulated experience from multiple fronts rather than a single event. The gap between written instruction and field reality narrowed incrementally, shaped by countless similar situations. The officer's role in this process remained indirect. He did not write manuals or issue directives. His influence was limited to those he trained and supervised. He emphasized steadiness, adherence to procedure, and respect for uncertainty. He discouraged improvisation unless no alternative existed, and even then, he insisted on restraint rather than speed. After the North African campaign concluded, his unit was reorganized. Personnel were transferred, promoted, or rotated out of the theater. Records became fragmented as administrative priorities shifted toward new operations. The mine incident did not follow him in any formal sense. It was not mentioned in subsequent evaluations or postings. In later years, when the war was documented and analyzed, such incidents rarely appeared in published accounts. Histories focused on battles, commanders, and strategic outcomes. The daily work of engineers, especially moments that ended without loss, remained largely invisible. Yet those moments contributed quietly to operational continuity, preventing disruption rather than creating spectacle. The mine itself, destroyed and buried again beneath shifting sand, left no physical trace. The ground where it had been laid was traversed many times afterward by vehicles and men unaware of what had once occurred there. The desert reclaimed the site, erasing the marks and signs that had once defined it as dangerous. What endured was less tangible. Among those who had witnessed the event, it reinforced an understanding shared across many units and theaters, that survival often depended on patience, discipline, and the ability to accept limits. Not every problem could be solved decisively. Some could only be managed until danger passed. The institutional legacy of such incidents was quiet adaptation. Procedures evolved slowly, shaped by accumulated experience rather than isolated acknowledgement. The system did not celebrate these moments, but it incorporated them indirectly, adjusting expectations and cautions over time. The officer eventually returned to civilian life after the war. Like many others, he carried experiences that were never formally recorded in histories or commemorations. They did not define his service publicly, but they informed his private understanding of risk, responsibility, and restraint. The story of a man who stepped on a mine and did not die is not one of dramatic rescue or sudden revelation. It is a record of controlled response under uncertainty, of systems tested at their edges, and of survival achieved without spectacle. Such stories seldom stand at the center of war narratives, yet they reflect the conditions under which much of the conflict was actually fought. If this account of a forgotten moment and an unsung role added perspective to how the war was lived on the ground, Consider supporting the continued sharing of these quiet histories.